So we're going to calculate a limit using a table. So before we've calculated the limit just by looking at the graph, but now I want to look at it, calculate the limit using a table. So we're going to make a table for x and for f of x, right? So we're going to put in the value of x, and then f of x will give us the output. So let's say they're asking us limit as x approaches 4 for the function x squared. Okay, so for this function x squared, we're going to plug in values from the left and from the right. So if we're going to plug in from the left, we're going to plug in a value in our calculator such as 3.99, and we're going to put it on our table. And so when we square 3.99, which is our function, we will get that, well, so 3.99 squared, it's 15.9 approximately. And when we plug in from the right hand side, 4.01, right? It's good to choose a value up to maybe the hundredths place. So when we plug in 4.01, then we're going to square that, so because that's the function. So 4.01 squared, and that's 16.08. So you see both of these are very, very close to 16. So we can safely say that the limit is 16. And this is how we would do it using a table. We don't have a graph, but we're just going to plug in values from the left and the right that are very that are close to the limit they told us, right? But what happens if we plugged it in from the left and we plugged it in from the right, but they were not the very similar numbers? For example, what if this was like 20, right? If that's the case, then we can say it does not exist, right? Because that means that our graph is looking something like this. There's probably an open circle and a closed circle, and the function is kind of off. That's why the positive and the negative, we have to check both of them when we are trying to use a table. So that's how we do it.